So now I'm working on problem 13, which is the cube root of 1 divided by 4. Now, just like what we've done with square roots, we can separate this radical. So up at the top, I can add the cube root of 1, and in the denominator, I can add the cube root of 4. Now, the cube root of 1 is just 1, so we don't need to worry about doing anything with that. Now, there's two ways you can approach this denominator. Well, we've got 4 here, so we can rationalize it by multiplying it by the cube root of 4 squared divided by the cube root of 4 squared. But I'm actually going to break that down. I'm going to go ahead and write that as 2 squared. Reason being is I just like to work with these smaller numbers. Now, what I'm going to have to do is I'm going to have to go ahead and rationalize that. The way I'm going to do that, I want to have something raised to the same exponent as my index. So I'm going to multiply that by the cube root of 2. Whatever I do to the bottom, I need to do to the top. And when I do this, I'm going to have that cube root of 2 in the top, and I'm going to have the cube root of 2 now to the 3rd power in the bottom. My index matches my exponent, and we have the cube root of 2 divided by 2. Now you could have done that using the cube root of 4 squared as your way of rationalizing. You just would have had to do a little bit more reducing it later. So this I just find is a quicker way to, again, reduce as I go, make my life a lot easier. Okay, for number 14, I see the square root of 2 divided by the square root of 3x. Now, looking at this, it looks like some of the ones up top where we combine that. But if I go ahead and look, if I combine that to be one fraction, there really isn't any reducing that I could do, and I would just end up splitting it back up eventually anyways. So I'm going to go ahead and just leave it like it is and rationalize the denominator. I'm going to rationalize it by multiplying by exactly what's there, square root of 3x. Got to do that in the numerator and the denominator. When I multiply that, I end up with the square root of 6x divided by 3x. And there is nothing more I can do with that one. Alright, 15. I've got the square root of 5 over 6x. Now 5 over 6x, there is no reducing that I can do. So I'm going to go ahead and split it up into the square root of 5 divided by the square root of 6x. At this point, it is very similar to what we just did in problem 14. So I'm going to multiply to rationalize my denominator by the square root of 6x times the square root of 6x. And when you do that, you end up with the square root of 30x over 6x. Now, I can't do any reducing here because that x is in the square root up there. $30, no way I can reduce that. It's 3 times 2 times 5. So that's my final answer for 15. Lastly, for 16. When I look at this one, it looks like one that I might be able to do some combining. So we've got the cube root of 2x squared. Excuse me, that's 2x to the third. divided by the cube root of y squared. Now when I look at that, I can do a little bit of reducing as I go. I see I've got the cube root of x to the third, so I can go ahead and pull that x out. You really don't have to show this step, but I just like to clean as I go. Now 2 divided by y squared, if I combine that to be one radical, there wouldn't be any reducing that I could do, so I'm not going to do that step. I want to multiply so that my index matches my exponent. So I'm going to multiply by the cube root of just y to the first, because y squared times y to the first will give me my y to the third that I want. So up at the top, I've got the cube root of y. And when I multiply those, I'm going to have x times the cube root of 2y. And I've got the cube root now of y to the third down at the bottom, which I can go ahead and reduce that down to y. So my final answer is x times the cube root of 2y in the numerator divided by y.